Good morning and welcome to the second section of Algebra 1, Chapter 7. Last time with Mr. Jordan, you worked on adding and subtracting polynomials. So our key there is to remember that we have to combine things that are alike. So we're looking for like terms and combining those. Today we're going to look at our second operation, which is multiplication. And what I'd like for you to think about today is using the distributive property. So we've talked about distributive property before. That's what we're going to build on today as we look at multiplying polynomials. Lots of other things will play into this, though, our exponent properties and some other things like that. Combining like terms, adding and subtracting will all come into play today. So let's go ahead and jump in. Our objectives for today are to be able to use different methods. So I'm going to share several different methods with you, and you choose the one that you think works best for you, or practice all of them because in different situations, different methods are most helpful. All right, so the first question says find the product of 3x and x minus 5 in parentheses. So the first thing we have to make sure is we understand that product is the answer that we get when we multiply two things together. So this just means I'm going to take 3x times x minus 5. Now, this should look familiar to you in the distributive property, what I asked you to think about before. And so distributing means I'm going to take this and multiply it into this term and multiply it into this term. Now, as we multiply, we have to keep a couple of things in mind. We have to keep our signs in mind, and we also have to keep our exponent properties in mind. So when I start by taking 3x times x, that actually becomes 3x to the second power. Because remember, repeated multiplication, x times x, can be written as an exponent, x to the second power. And then when I multiply the 3x times the negative 5 or the minus 5, 3 times 5 would become negative 15, and I would still have that x there. So that's the distributive property way of doing this problem, and it's a perfectly fine method of doing this problem. However, sometimes another way of organizing this is something called the box method. And the box method is really just the distributive property, but using a box instead to help you keep it straight. So the way that it works is this. Since I'm multiplying a monomial, one term, I'm going to make a box that has only one level horizontally. And then I'm multiplying by a binomial, two terms. So this one's going to have two pieces on the top. And then I'm just going to find the area of each box, that's what multiplication is, by multiplying. So this box here is found by taking 3x times x, which is 3x squared. And this box here is found by taking 3x times negative 5, which would be negative 15x. Now you'll see the same pieces are what I got as my answer up here when I use the distributive property. So really it's up to you which method you like. As we continue out through our lesson today, I'm going to be just going back and forth. And so as you're working problems, if you like box method and I use the distributive property, we should end up with the same answer and actually even the same pieces as we work. All right, so let's move on and see what our next piece will look like here. This one says, what is the product? So again, multiplication of negative 4x to the third, and then the trinomial x squared plus 3x minus 4. So again, you can either set this up as a multiplication with the distributive, so negative 4x to the third times x squared plus 3x minus 4. Or you can set this up using the box method so that because it's a monomial, I would have one row. And because it's a trinomial, I would have 3 columns. And I would have x squared, 3x, and negative 4. Now I've set them up both ways, but I'm going to go ahead and do this problem using the distributive property, but I would get the same thing if I use that box method. So 4x to the third times x squared, that's a negative 4x to the third, would become a negative 4. And then x to the third and x to the second. Remember, when we multiply those exponents or multiply those bases, we add the exponent. So it becomes x to the fifth power. And then when I take that negative 4x to the third times 3x, so negative 4 times 3 is negative 12. And then x to the third with another x becomes x to the fourth. And then finally, negative 4x to the third times negative 4. So negative times negative becomes a positive 16. And no other x's to combine, so I just write it as x to the third. When I finish, I want to look at my answer and see if there are any like terms that I can combine. And in this case, I have x to the fifth, x to the fourth, and x to the third. Those are all different, so no combinations that I would need to make there. All right, last problem. I'll go ahead and erase what I wrote there so you can see this one. Go ahead and set this one up in whatever method you would like to use and give it a try and see what you get on this one. All right, so I'm going to choose to use box method on this one since I did distributive on the last one. And I end up with negative 2x squared, and then I'm multiplying by a trinomial, so I'm going to have three pieces up here on top, x squared, 3x, and 4. And when I multiply, I'm going to end up with negative 2x to the fourth, a negative 6x to the third, and a negative 8x squared. So my answer now would be negative 2x to the fourth minus 6x to the third minus 8x squared. I just put all those pieces together, and since there are no like terms, I can't combine any of them. All right, let's take a look at the next set of problems then. Right, this one looks a little bit different because no longer do I have like a monomial times a binomial or trinomial or something like that. This time I have a trinomial times a trinomial. So distributing is a little bit tougher on this one because I don't see those pieces that I can distribute. I don't see one monomial that I can take to every term. Now, there still is a way that we can use the distributive property, and I'm going to look at that one second, but I want to first tie this one to the box method. So this is a binomial, so it's going to have two parts, so I'm going to have two rows in my box. And then another binomial, so this time I'm going to have two columns in my box. And so I'm going to separate this as an x plus 5, and then this one is an x minus 8. So now I've got to multiply to get the area of each of those little boxes. So this first box is found by taking x times x, which is x squared. The second box is found by taking x times negative 8, which would be negative 8x. All right, this one here is found by taking 5 times x. That's called 5x. And finally, 5 times negative 8 gives me negative 40. Now, this one's interesting because as I do that multiplication, I'm going to see that there are some like terms in this one. And so when I write my final answer, I'm going to go ahead and combine the things that are alike. So starting with the x squared, I don't see any other x squared, so I'm just going to have x squared. But when I combine 5x and negative 8x together, that becomes negative 3x. Here's where that adding and subtracting comes that we talked about last time. And then finally, the minus 40 has no other like terms, so it just becomes part of my final answer. So when I finish, I know I'm finished because I don't have any like terms in that answer to combine. Now, I told you that we could also use the distributive property, and we can here. And to help us do the distributive property correctly, we're going to use a word called FOIL. Now, the only reason we used FOIL is because that's a word that we're already familiar with, and it helps us keep track of what we're doing here. What the F stands for is the first term. The O stands for the outer term. The I stands for the inner term. And the L stands for the last terms. And so what this means is we're going to distribute in this order. First, we're going to take the first times the first. So x times x. x times x would give me x squared. Then O says to do the outer term, so outer would be x times the negative 8. So x times negative 8 is negative 8x. Do you see how we've distributed the x, the first x here, to each term in the second binomial? All right, now we go to I. I says inner terms, so that would be these two terms here. So 5 times x would be 5x. And finally, the last terms means the last of each of the binomials. So 5 times negative 8 becomes negative 40. All right, just like before, oftentimes it's those middle two terms, but we can combine those together because they're like terms. So I bring down the x squared, no like terms, but negative 8x and 5x becomes negative 3x. And then I finally have the minus 40 at the end. All right, let's try one more together. They ask here, how can you use the distributive property to multiply these two binomials? Again, box method or FOIL method is using the distributive property. They're just different ways of organizing. So you can choose whichever method you like. Try one, then maybe try the other, or if you're struggling with one, try the other and see what you think. We'll do this one with the FOIL method first. So FOIL says first times first. So 2x times x would be 2x squared. O stands for outer, so that's 2x times negative 5. That would be negative 10x. There's a lot to keep track of here. Watch those signs. I stands for inner, so 4 times x would be 4x. And then finally, L stands for last, so 4 times negative 5 would be negative 20. And then remember, we want to combine those things that are alike. And so 2x squared has nothing like it, but negative 10x and positive 4x would become negative 6x. And then finally, we have that minus 20. I'm going to put another problem or two up here. You guys go ahead and give these a try in whichever method you want. I'm going to do one with FOIL and one using the box method. And you check your work and see how you did. So my answer here on A would be 10x squared minus 3x and minus 4. And then my answer here on B would be 6x squared plus 2x minus 20. So again, as you work through these problems, multiplication, we're using the distributive property. We're just organizing it either using the FOIL method or using the box method. Both are equally good methods. It's really just a matter of what you prefer. All right, let's try a couple of challenge problems here. In this case, they ask us to find the product, so that's still multiplication, but this time they're asking me to find the product of a trinomial and, oops, I went back, a trinomial, 3 parts, we'll get it here, and a binomial, 2 parts. So box method still works great here. Trinomial means I'm going to have 3 rows, and binomial means I'm going to have 2 columns. And so I'm just set that up as an x squared, a 2x, and a negative 1, and then the 3x and the plus 4 up top. And this time I just have 6 pieces that I'm filling in. So x squared times 3x becomes 3x to the third. X squared times 4 becomes 4x squared. 2x times 3x, well, the 2 times 3 is 6, and x times x becomes x squared. 2x times 4 becomes 8x. Negative 1 times 3x becomes negative 3x, and negative 1 times 4 becomes negative 4. Now, to write my answer here, I'm going to go ahead and look for like terms. So I start with the 3x to the third, and I see no other x to the third. So I'm just going to bring that one down. 4x squared, oh, I see some more x squared. So I can put those together. And so 4x squareds and 6x squareds together become 10x squareds. I see an 8x and a negative 3x, again, like terms. So I can put those together and get 5x. And then finally, I've got this number out here by itself, minus 4. Now this one, if I wrote it to use the FOIL method, if I did 2x squared or x squared plus 2x minus 1, and then times 3x plus 4, take a look what happens with the FOIL method. If I do first times first, I end up with 3x cubed. If I do outer times outer, I end up with 4x squared. Inner times inner, I end up with negative 3x, and last times last, I end up with negative 4. Do you see how I've completely ignored this 2x? So FOIL method using those letters, F-O-I-L, only works if it's a binomial times a binomial. However, the idea behind the FOIL method works no matter what size we're multiplying. So what it means is this: I need to make sure I multiply this x squared by every piece in the second binomial. Then I need to make sure I multiply the 2x by every piece in that second binomial, and that's the part I'm missing. And then finally, this last part by every part in that second binomial. So in order for me to do this, I would need to add 2 more parts here. The 2x times 3x, that would give me 6x squared. And the 2x times 4, that would give me 8x. So I can use the FOIL method here. I just can't stick with just those 4 letters. I have to make sure I use all of the pieces. So let's try one more. This time I'm going to use the distributive property or the FOIL method. But again, I have to adjust it a little bit. And so I'm going to start by taking 2x and multiplying it by every single part in my second binomial or trinomial. So 2x times negative 3x squared becomes negative 6x to the third. And 2x times 4x becomes 8x squared. And finally, 2x times negative 4 or negative 7 becomes negative 14. Now I'm just going to repeat that process, but multiplying my negative 5 by every part of that second trinomial. So negative 5 times negative 3x squared becomes positive 15x squared. And negative 5 times 4x becomes negative 20x. And finally, negative 5 times negative 7 becomes positive 35. And then I want to go ahead and combine things that are alike. So I start with my first term, nothing like it, so I just bring it down. Then I go to my x squareds. Oh, I see some more x squared. So when I put them all together, I end up with 23x squareds. I have a negative 14, and that would combine with my 35. So negative 14 and 35, that would become a 21. And then finally, I have this minus 20x written behind. Guys, this is a perfectly fine answer. However, most times we write our answer in standard form. So if you'll remember, that just means biggest exponent down to smallest. And so you may want to rewrite it, or you may see it rewritten as negative 6x to the third, 23x squared, minus 20x plus 21. All right, guys, I hope that helps you get started on your work today. You're going to be working on your Pearson assignment 7.2, practicing those multiplications. of different polynomials. Let us know if you have any questions. We're happy to help. We'll talk to you later. Bye.